Hi, my name is Radhika. Welcome to my Add Maths classes. In this video, you will see the 2021 paper 11 of Add Maths solved. So you will see question numbers 1 to 5 in this video. For question numbers 6 to 10, please click on this link. This link is also provided in the description box.
Hello students, let's start from the first question. On the axis, sketch the graph of y equal to 5 into x plus 1 into 3x minus 2 into x minus 2. This is the equation of the graph given, stating the intercepts with the coordinate axis. So we have to draw the graph and we have to show the points where it is cutting the x and y axis. Alright, so if you expand this equation, we will find that it is a cubic equation. So the first terms, if we multiply 5x, 3x and x, we see that it is a cubic equation. Then rest of the terms follow. Now we know the graph of cubic equation to be either this way, depending on the sign of the coefficient of x cube. If the x cube coefficient is positive, this is the graph. If the x cube term coefficient is negative, this is the graph. So since the coefficient of x cube is plus 15, the graph is going to be this one. So now we know the shape of the graph. Let us see where at what points it is cutting the x-axis and at what point, if at all, it cuts y-axis. Alright, first let us find the x-intercept. So this is found by putting y equal to 0 in the equation. So if you substitute y equal to 0, this is what we get. So if the product of three brackets is 0, that means the brackets, any one of the brackets must be 0. Or x minus 2 is 0. So from here we get x equal to minus 1, x equal to 2 over 3 and x equal to 2. So these are the three x-intercepts. Now the second point is finding y-intercept. So y-intercept is found by substituting x equal to 0. So in this equation, if you substitute x equal to 0, let us see what we get. 0 plus 1, 0 minus 2 from the second bracket, 0 minus 2 from the third bracket. So this simplifies to 5 multiplied by 1 multiplied by minus 2, which we get 4 times 5 is 20, and this is going to be positive 20. Alright, now that we got the y and x intercepts, let us proceed to draw the graph. So after knowing the y and x intercepts and knowing the shape of the graph, we are ready to draw the graph. So this is going to be the shape of the graph. Alright, so this is the answer for 1A. Alright, now we'll look at part B. Hence find the values of x for which the equation or the y value is greater than 0. So this we can get directly from the graph. So our graph was like this. This was minus 1, this is 20, 2 over 3 and this one was 2. So find the values of x for which y is greater than 0. So y greater than 0 is above. So you can see for what values or within which values the y value is greater than 0. If you see, this is the part of the graph where y value is less than 0. Whereas between these two and above this, the value is greater than 0. Again, value goes in the negative y value. So the values of x that satisfy y greater than 0 are x greater than minus 1, We won't say x greater than equal to, because when it is equal to, it is exactly 0. But the question is why it should be greater than 0. So x greater than minus 1. So we are covering all this region now. And x less than 2 over 3. Okay, so these two conditions we can combine and write x greater than minus 1 less than 2 over 3. So this is one range of values for which y is greater than 0. But as you can observe from the graph, y is greater than 0 after 2 also. So, and x greater than 2. So there are two conditions, that sets of values of x that satisfy y greater than 0. And the answer is this box and this box here. Okay, now on to question number 2. Find the integration of two fractions separated by a negative sign. Alright, so this is called limited integration. So 3 to 5, 1 over x minus 1 minus 1 over x minus 1 whole square dx. So we have to integrate the two fractions, and the answer should be given in the form a plus ln b, where a and b are rational numbers. What are rational numbers again? They are the numbers which can be represented as a fraction. Alright, so as we know, any plus or minus we can split into two different integrals. So I mean, we can do this 1 over x minus 1 dx minus integration 3 to 5 1 over x minus 1 whole square dx. So the formula for integration of 1 over x minus 1 is natural log x minus 1 with the limits from 3 to 5 minus the integration of this one. So this one we can write it as integration x minus 1 power minus 2 dx. So we know from here is that it is x minus 1, the power we will add 1. So it is minus 2 plus 1 divided by minus 2 plus 1. So this comes to be x minus 1 power minus 1 divided by minus 1. So that will make it minus 1 over x minus 1 limits 3 to 5. Alright, so we'll continue here. So by applying the limits, we get ln 5 minus 1 minus ln 3 minus 1 from the first integration minus 1 over 5 minus 1, minus of minus becomes plus 1 over 3 minus 1. So we get ln 4 minus ln 2 minus these two minus will make it plus 1 over 4 minus and plus make it minus 1 over 2. So from the logarithmic rules we know that ln, this becomes ln 4 by 2. Why? Because we know ln of a divided by b can be written as ln a minus ln b. So ln a minus ln b can be written in the form like this, which we are using it here. So plus 1 over 4 minus 1 over 2 minus 1 over 4. So ln 2 minus 1 over 4. So we brought into the form a plus ln b. So we can identify a and b now. So a is minus 1 over 4 and b is 2. And that is the answer for this question. Alright, we are going to question number 3. The polynomial px given as ax cube minus 9x square plus bx minus 6, where a and b are constants, has a factor of x minus 2. This has a factor x minus 2. The polynomial has a remainder of 66. So it has a remainder of 66 when divided by x minus 3. Find the value of a and b. Okay. Given that x minus 2 is a factor, that means when x is equal to 2, this polynomial value becomes 0. That is the factor. That means it is the value of x which brings this polynomial value equal to 0. So we will use that fact. So we will substitute x equal to 2 here. So it is a into 2 cube minus 9 multiplied by 2 square plus b into 2 minus 6 is equal to 0. So this gives us 8a minus 4 multiplied by 9, 36 plus 2b minus 6 equal to 0. So we get an equation with a and b like this. So we simplify it by dividing by 2. We get 4a plus b is equal to 21. So this is our first equation in solving a and b. So we have to get another equation in a and b using the second data, remainder of 66 when divided by x minus 3. And those two equations we will solve as simultaneous equations. Okay, so let me write this equation on the top here. 4a plus b equal to 21 is our first equation. So we will go for the second equation now. So when divided by x minus 3, it gives a remainder of 66. That means when x is equal to 3, the value of the polynomial becomes 66. So we will substitute x equal to 3 now. So it is a into 3 cube minus 9 into 3 square plus b into 3 minus 6 equal to, this time it is not 0 because it is not a factor, but it gives a remainder of 66. So we will equate it to remainder 66. This gives us 27a minus 9 into 9, 81 plus 3b minus 6 equal to 66. So clubbing a and b terms, this is minus 87, it becomes plus 87, so it will be 153 onto the right side. So we divide by 3, it is 9a plus 1b is equal to 51. So this is going to be our equation number 2. So using this number 1 and number 2, we can solve simultaneous equations to find a and b. So this is our first equation, 4a plus b is 21. Second equation, 9a plus b is equal to 51. So as we can see, we have b and b. So subtracting equation 2 from 1, that is by doing 1 minus 2, we can cancel out b. So when I do 1 minus 2, the second equation's sign will change, which we will write like this. So now we will see it is 4a minus 9a, I get minus 5a, plus b minus b cancel out each other, equal to minus 51 plus 21, I get minus 30. So this gives me a is equal to 6. From equation 1, we substitute value of a and get b value. So 4 into 6 plus b equal to 21. So I get b equal to 21 minus 24, which is negative 3. So these two are the values of a and b. This is the answer for part A. Now going to part B, using your values of a and b, show that p of x equal to x minus 2 into q of x, where q of x is a quadratic factor to be found. Alright, So after knowing a and b, let us substitute them and rewrite the value of p of x. Now p of x looks like 6x cube minus 9x square minus 3x minus 6. Now it is given that x minus 2 is a factor. This means that when we divide the polynomial by x minus 2, we get a remainder of 0, and the quotient will be the another factor. It is like, for example, the number is 24. Let's say p of x is 24. If I tell you 3 is a factor of p of x, so what does that mean? I can divide p of x, which is 24, by 3, and what I get is a quotient remainder 0. So this quotient is another factor of p of x. So now we are going to find another factor for this polynomial by dividing the polynomial by the known factor. Okay, so to get 6x cube, what I need to multiply this x with? It is 6x square. So when I multiply by 6x square to x, I get 6x cube. So that is my goal, to get this same term here. So I got that. Then I have to multiply this divide by minus 2 also. So which will give me minus 6 into 2, 12x square. Now I am going to subtract. So remember, when you subtract algebraic expressions, change the sign of the second equation or second expression. So this plus 6x cube minus 6x cube will cancel. Minus 9x square plus 12x square give us 3x square. Now it is time to bring down the next term, which is negative 3x. So to get 3x square, what I need to multiply to x? I need to multiply by plus 3x. So which I am going to write here, plus 3x. Now with this plus 3x, I am going to multiply to both x and minus 2. So 3x multiplied by x is 3x square. Minus 2 plus 3x, I get minus 6x. Now we are subtracting. Remember to change the signs. The first terms cancel each other. What I get from the two terms is plus 3x. Now it is time to bring down the last term, minus 6. So if I need 3x from x, I need to multiply by 3. So I'm going to write plus 3. So plus 3 into x, 3x, minus 2 into 3, minus 6. So I change the signs and I see that all the terms cancel each other, leaving behind a remainder of 0. So this shows us that this is another factor. So x minus 2 is a linear factor, and this one, 6x square plus 3x plus 3, is called the quadratic factor. So the answer for this part B is, the quadratic factor that we got is 6x square plus 3x plus 3. Alright, so we have the third part to this. Hence show that the equation p of x is equal to 0 has only one real solution. Okay. So we have to now find the roots of this polynomial. So we have already factorized this polynomial, and they are the two factors. One is linear factor x minus 2 and another quadratic factor 6x square plus 3x plus 3. So the roots of any polynomial are found by equating the polynomial to 0, and which leaves us equating each of the bracket to 0. So we equate the first bracket to 0, we get x equal to 2. Now we equate the second bracket to 0, and we have to find the values of x. Now we have to show that it has only one real solution. That means the real solution is only x equal to 2. This should not be giving us any real solutions. It should be giving us imaginary solution. So we will test this first by calculating the b square minus 4ac, which is called the determinant, which decides what kind of roots quadratic equation has. So as you can see from the equation, we have a equal to 6, b equal to 3 and c also equal to 3. So b square minus 4ac, we get 3 square minus 4 into a into c, which is 9 minus 72. This gives us minus 63. So square root of b square minus 4ac is square root of minus 63, which is less than 0, gives imaginary solutions. Therefore, this polynomial has only one real solution, which is x is equal to 2, and hence proved. Okay, let's look at question number 4. The first three terms in the expansion of a plus x whole cube multiplied by 1 minus x over 3 power 5 in ascending order of x, that is from the lowest power of x to the higher power of x, can be written in the form 27 plus bx plus cx square, where a, b and c are integers. Find the values of a, b and c. So now we have to multiply these two brackets and look for the terms of x in the ascending order. Alright, so let's expand the brackets separately first so that it is easy to multiply the terms. Okay, so according to the binomial expansion, we start from this index 3c0, then the first term to the power 3, second term to the power 0, plus we increment this number 3c1, decrement this power, increment the second term power, plus 3c2 a cube x square plus 3c3 x power a power, sorry, here it is a power 1, a power 0, x power 3. So simplifying, what we get, 3c0 is 1, so it is a cube plus 3c1 is 3 a square x plus 3c2 is also 3 ax square plus 3c3 is 1, so that is x cube. Now similarly we will expand the second bracket, x over 3 whole power 5. So it is 5c0, so 1 power 5 into x over 5, sorry, x over 3 power 0. Then we have a minus here, so the terms will have alternatively plus and minus. The first term is plus, the second term is going to be minus 5c1, 1 power 4, x by 3 power 1, plus 5c2, 1 power 3, x over 3 whole power 2, minus so on. We wouldn't need all the terms here. Why? Because we are interested only in the terms which have x power 0, x power 1 and x power 2. We are not interested in x power 3 onwards, so we don't have to write all the terms. Alright, so after the expansion, let us simplify this. So 5c0 is 1, 1 power 5 is 1, this bracket power 0 is also 1, so that will give us a 1, minus 5c1 is 5, 1 power 4 is 1, it is x by 3, plus 5c2 is 10, 1 power 3 is 1, x square divided by 3 square, which is 9, minus so on. Alright, now we got all the terms. We will now work with the expansion of both the brackets to find out which all qualify to be the x power 0, x power 1, x power 2. Now let us carefully observe and see which all terms multiplied together give us a constant. That means without any x. So this is the constant. So this constant, when multiplied to a constant from the second bracket, they give us the constant. But if you observe all other terms, they will have an x with them. So they can't give us the constant. So it is a cube multiplied by 1, which is equal to a cube, must be the constant. And it is given that when these two are multiplied, the first terms are like this, which clearly shows 27 is the constant. So that means a cube must be 27, which tells us a is equal to 3. Now, we will now observe and see which all terms from both the brackets give us an x term. Which terms give us x term. So when a constant is multiplied with an x term from the second bracket, or if you see a cube multiplied by 1 is a constant, a cube multiplied with the x term is a x term, but a cube multiplied with x square is x square term. So no more terms from here. Now we will select the term, an x term from here should be multiplied to the constant from the second one. So those two products are the ones which give us the x term. Okay, so let's do that. A cube into minus 5 over 3 plus 3a square into 1 are the x terms which is b. Okay, so let us substitute a square here and a cube here. So 3a is 3, so 3 cube multiplied by minus 5 over 3 plus 3 into a square. So it gives us minus 45. 1 3 cancels with this one, leaving 3 square. 9 into 5 is minus 45 plus 3 cube, which is 27. This gives us negative 18, which is the value of b. Okay, now the last part to find c. As you can see, c is the coefficient of x square. Let us examine which all terms multiplied will give us an x square. So as you can see, we'll start from the constant multiplied to the x square term here. Then this x term when multiplied to x term here. And the third one is x square term multiplied to constant here. So we have three products contributing to the x square term. So let us carefully multiply them and see. Okay, so a cube when multiplied with the x square term of the second bracket. So what do we get? A cube into 10 over 9. Then the x term multiplied with the x term here. So if you see carefully, plus and minus gives us a minus. 3a square into 5 by 3. 3a square into 5 by 3 is the coefficient of x. Observe, we don't need x, we are concentrating on the coefficient only. And the last term is 3a square multiplied to 1. So that gives us 3a. All these are x square terms. So now we will substitute value of a and simplify. 3 cube over 3 cube multiplied by 10 over 9 minus 3 into 3 square 5 over 3 plus 3 into 3. So as you can see here, 9 into 3, 9 cancels with this, leaves us 30 minus 3 cancels, 45 plus 9. So it is 39 minus 45 gives us negative 6. So our a value is 3, b is negative 18 and c is negative 6. Now we see how to solve the fifth question. The functions f and g are defined as follows. F of x is equal to x square plus 4x, x belongs to the set of real numbers. G of x is equal to 1 plus e power 2x, x belongs to the set of real numbers. Now part A, find the range of y, the range of f, range of f. So the range of f is nothing but the value of y-axis. So if we are going to plot this on the graph, you can see that this is a quadratic equation with a 1, b equal to 4 and c equal to 0. We know that this results in a quadratic equation, it is in a parabola which is a concave up, because the x square coefficient has a positive sign, so it is a concave up parabola. So we find that there is a minimum value which we call it as vertex. So as you can see, the f of x value, which is nothing but the value of the y-axis, is above this minimum value. So the range of f we can get by first getting the minimum value of f. So from the quadratic equation, we know that the minimum value happens for x value, which is given by minus b by 2a. So substituting b is the coefficient of x, we get minus 4 over 2 into a is the coefficient of x square, 1. So we see that it is minus 2. So if this is x is minus 2, so when x is minus 2, the graph shows a minimum value, this one. Okay, so now we will find what is the corresponding value of y for this. So substituting x equal to minus 2, we get f of minus 2 is equal to minus 2 whole square plus 4 into minus 2. This gives us 4 minus 8 as minus 4. So this corresponding value is minus 4. On the other hand, we can say the vertex is minus 2, minus 4. We can see from the graph that the minimum value starts with minus 4 and the value of y, which is nothing but the value of f of x, increases on either sides. It never goes less than that, and hence we can say the range of y at the f of x, range of f like this: f of x greater than or equal to negative 4. Now we will see how to solve part B. Part B says write down the range of g. So write down the range of g. So we have to find the least value that g can take. So if you see the equation, it is 1 plus e power 2x. We know that e power 2x, the least value possible, the minimum value is 0. So it can't go negative. Even if x is negative, e power 2x is going to be a positive value. So we see that e power 2x can never become less than 0. So the minimum value is 0. So the g of x will be 1 plus 0 is always 1. So the minimum value of g is 1. So all other values of g will be more than 1. Because e power 2x is always positive. Though it is a very small value, it is a positive value. Therefore, g of x is going to be greater than 1 always. Therefore, we write the answer range of g of x, we will write like this: g of x greater than or equal to 1. Okay, now let us see part C. Find the exact solution of the equation f of g of x is equal to 21, giving your answer as a single logarithm. Now f of g of x is called a composite function. Now for simplicity's sake, let's say g of x is equal to a. So it is given that f of a is equal to 21. We can write it like this. So from the function f of x, we can write f of a as a square plus 4a is equal to 21. Now rearranging this, we get a square plus 4a minus 21 equal to 0. So if you apply the formula for solving the quadratic equation, so you have to find the formula like this: minus b plus or minus b square minus 4ac divided by 2a. Apply the formula and substitute a, b and c. So a is 1, b is equal to 4 and c is negative 21. If we put these values and calculate, we find that we get two values of a, which is a is equal to 3, a is equal to negative 7. Now from the previous part b, we saw that g of x is always greater than or equal to 1. So a of negative 7, a value of negative 7 for a, nothing but the g of x value, cannot be minus 7. So hence we discard this value. We will accept a equal to 3. So substituting a equal to 3, we get 1 plus e power 2x is equal to 3. Rearranging gives us e power 2x is equal to 2. Now going by the basic logarithmic definition. So what is the definition? ln of a is b, let's say. So ln is natural log with base e. So we can write this as e power b is equal to a. So using that, we can write ln of 2 is equal to 2x. So from this we get x is equal to ln of 2 divided by 2, which will be, we can rewrite it as half ln 2, which we can again write it as ln 2 power half, which is ln square root 2. Note that we used a formula here which says ln power x power n is always n into ln x. You can bring this index down and write ln x. So if it is in this form, we should be able to write like this, which we are using it here. The number that is multiplied, we bring it to the power of 2. So 2 power half is nothing but square root 2. So the answer is f of g of x is equal to ln square root 2.